A 10 centimeter long rod carries a charge of 50 microcoulomb distributed uniformly along its length. Find the magnitude of the electric field at a point 10 centimeter from both the ends of the rod. So suppose here is our rod and this is a point which is at a distance of 10 centimeter from both the ends. Here these distances are 10 centimeter and even the length of the rod is also 10 centimeter. That means it is a equilateral triangle that we'll use later on. So first of all, let's understand that how to calculate the magnitude of electric field at this point, which is basically the perpendicular bisector of this rod. Suppose we have uniformly distributed the whole charge. Here length is given to you is 10 centimeter. Later on you can substitute the values. For now we will be using the length L, and the charge carried by this is 50 microcoulomb. So 50 into 10 to the power minus 6 coulomb. So we can always calculate the value of the lambda, which is Q by L, charge per unit length. And suppose here this is our origin, and select a particular segment at a distance y from the origin up to a distance dy, and suppose this particular angle is theta and this distance is r, and suppose here this particular distance is d. Okay, then because of this segment, electric field at this location will be, suppose we are assuming the positive charge on this rod, so along the line joining the charge and the point, along that line electric field will lie. So because of this segment, electric field will be pointing in this direction, let it be DE dash suppose. And consider the similar element on the other side, because here this point is basically on perpendicular bisector. So we'll get similar components, similar segments on both sides of this point, which is the center of the rod. So if we consider the same segment here, then its electric field will be directed along this direction, and these two fields will be of the same magnitude, dE dash equal to 1 divided by 4 pi epsilon naught into charge on this segment is lambda into dy divided by square of the distance, which is r square. So this is dE dash, and if suppose this angle is theta, then this angle is also theta. So here this angle is also theta. So d dash component in this direction will be d dash cos theta, and for the same, for here d dash, it will be d dash cos theta in the same direction, but the other components will be oppositely directed, which are dE dash sin theta and dE dash sin theta. So these two components will get cancelled. So net field will be only because of this horizontal component. So what we can do is to find the net electric field at this particular point will be in this direction. E net will be in this particular direction. This is the direction of net electric field at this particular point. Okay, d dash cos theta, which is along this line of perpendicular bisector, and E net is equal to integration of d dash cos theta for the complete rod. If we multiply it with the 2, then we have to integrate for the half rod. Okay, that we can consider later on. Anyway, let's substitute these values here. So it becomes d dash is 1 upon 4 pi epsilon naught into lambda into dy divided by r square into cos theta. Actually, we want to use theta as the limits of integration, and suppose this particular angle here is theta naught. In this case, because here it is given to be 10 centimeter, 10 centimeter, and the length of the rod is also 10 centimeters. So here this angle theta naught in this particular question is just 30 degree. So this question will be the special case when theta naught is 30 degree. Okay, so here as you can see that these y, r and theta, these three are interrelated. So we can apply, suppose tan theta. Tan theta is equal to y divided by d, as you can see that in this triangle. So it means y is equal to d tan theta. That means if we differentiate it with respect to theta, dy by d theta, what it becomes? It becomes d multiplied with what? Sec square theta. So in place of dy, we can substitute d sec square theta into d theta. Okay, so here d is the distance and d theta is for the angle segment. So this is dy in place of dy. And in the same way, as you can see here in this triangle, that sec of the angle theta is equal to r divided by d. That means r is basically d sec theta. So now substitute these values, the value of dy and r, in this particular equation. So E net becomes how much? Integral of 1 upon 4 pi epsilon naught into lambda into dy. So in place of dy, we need to substitute d into sec square theta into d theta. That is placed in place of dy divided by r square. R square is d square and sec square theta. Okay, multiplied with cos of theta, and limit of integration will be minus theta naught to plus theta naught, because here the angle we are increasing in upward direction or in the clockwise sense, so anti-clockwise will be measured as negative angle. So minus theta naught to plus theta naught. So here you can see that sec square theta gets cancelled, and here it becomes lambda divided by 4 pi epsilon naught into d. Lambda divided by 4 pi epsilon naught into d, after this d gets cancelled, and inside the integration it remains cos theta d theta from minus theta naught to plus theta naught, or we can just double it by multiplying it with the 2. So I am just making it to 2 in place of 4. So 2 pi epsilon naught d integral 0 to theta naught of cos theta d theta. Okay, so here I have multiplied it with the 2 and changed the limit to 0 to theta naught. So now what we get, E net equal to lambda divided by 2 pi epsilon naught into d, and integral of cos theta. Cos theta integral is what? Sin theta from 0 to theta naught, upper limit minus lower limit. So it becomes lambda divided by 2 pi epsilon naught into d into what? Sine of theta naught. Okay, so final answer in this case what we have got is lambda divided by 2 pi epsilon naught d sine theta naught. So this is the final answer to the question, and its numerical value can be calculated by substituting the value of the theta naught. Here theta naught is given to be 30 degree, and the value of the d can be calculated. Here the value of d, it is 10 centimeter, it is 5 centimeter. So in place of d we can substitute under root of 100 minus 25. Okay, so d can be calculated, lambda, here the value of lambda can be calculated. So these things you can do on your own. And one more thing here I would like to tell you, that this was a case of perpendicular bisector. That is why sine theta components are getting cancelled. In case it is not the perpendicular bisector but the point is somewhere else, in that case we need to integrate both the components, d dash cos theta, d dash sine theta. Okay, we need to integrate both these components separately in order to, and these two components will be existing in terms of the angles that the lower end of the rod makes with this line and upper end of the rod angle it makes with this line. Okay, but for this question this calculation is sufficient.